welcome back to the Edexcel Hub. Today I'm going to be talking about Chapter 2, Elements, Compounds and Mixtures. First of all, what are elements? An element is a substance made up of only one type of atom, and all the atoms in an element have the same atomic number. So the atomic number is the number of protons in an atom. And there's a better way of saying this, since saying that all the atoms in the element have the same atomic number is a better way of explaining what is an element, because elements have isotopes, which are atoms with different number of neutrons and the same number of protons. So when you say that an element is made up of only one type of atom, there are different isotopes of that. It cannot be split into anything simpler by chemical means, since this is the simplest form of a substance. For example, magnesium metal, it has only magnesium atoms in it. So here is an example of a pure metal. The diagram is there and it shows all the atoms are the same. Next, what are compounds? A compound is a substance which is made up of two or more elements chemically combined together in fixed proportions. The properties of the element in a compound can change. It does not always have to have the same property of the element in the compound. And compounds can only be separated using chemical means and not physical means, because as I said before, a compound is made up of elements which are chemically combined, so they cannot be separated using physical means. For example, there's sodium chloride, which is NaCl. And here's a diagram to show you the configuration or how a compound looks like. So this can be an example of H2O, because there's one hydrogen atom for every two oxygen atoms. So they're always in this fixed proportion. Next, what are mixtures? A mixture is a combination of two or more compounds in random proportions. In compounds, they're in fixed proportions, whereas in mixtures, it's in different random proportion, and they're not chemically combined, they're physically mixed together. And since they are physically mixed together, they can also be separated using just physical means, and the substances do keep their properties in a mixture. For example, the salt water, and here's the diagram to show how salt water looks like. So there are different types of atoms, there's different types of proportions, there's no fixed proportions. Next, here's a comparison between pure substances and mixtures. So pure substances only have one single element or compound, and mixtures, they can have two or more different elements or compounds. And pure substances, they are chemically bonded, so they can only be separated using chemical means. But mixtures, they are not chemically bonded, and so they can be separated using physical means, as they are physically mixed together, as I stated before in the previous slide. And usually compounds, which are a form of pure substances, they do not keep their own properties, whereas mixtures always do keep their properties. A good example of this is when you have a mixture of hydrogen and oxygen. This forms a colorless gas which will explode when you put a flame to it, and it will catch on fire. But water, which is a compound, it is a colorless liquid which shoots out a flame. So you can see the difference in that. So in the mixture, it does keep their own properties. So both of them are gases, so the mixture will also be a gas. And in the compound, even though they're formed by two gases, the result becomes a liquid, and instead of it catching on fire, it will put out a flame. The next point is pure substances melt and boil at a specific temperature always, and that temperature is known as its melting or boiling point. Mixtures, on the other hand, can have a range of different melting and boiling points, because they are having different types of substances in the mixture, and they can melt over a range of temperatures. This range is caused because the different types of substances will lower the melting or boiling point and increase the range between them. This also helps identify or distinguish between a pure substance and a mixture. It also helps to know the purity of a substance. So if they have a larger range, it's more impure, But if it melts at a specific temperature, then you will know it's more pure. Then pure substances do not contain any impurities. Impurities are just unwanted substances, so they do not contain any impurities, just the pure element or compound. But mixtures, they can have a few impurities. An example of a pure substance is H2O, or even any element like magnesium or sodium. And mixtures, for example, was air, which consists of different gases like nitrogen and oxygen. Next, we have the cooling curve. So here there's an example of a cooling curve for an impure substance versus a pure substance. As you can see in the first graph, for an impure substance, it produces a gradual decrease in temperature because there are different types of substances and impurities in it. So there's a bigger range of melting point. Whereas in a pure substance, you can see the horizontal part shows that the substance has a sharp melting point, therefore it is pure. That's all from me today. Thank you so much for watching, and if you like this video, please give it a thumbs up and subscribe to the channel for more videos, and don't forget to share to your friends. Have a great day.